In this video, I am focused on the math concepts that are typically associated with any Physics 1 course. This is the first of 3 videos in my Unit 1 titled Math Review. If you want to practice what is covered in this video, then check out the video description. You can find a link to my worksheet 1.01 as well as video answers for each problem. Let's start with unit conversions. There are 3 of them that are commonly seen. Length measurements should be recorded in meters, mass measurements in kilograms, and time measurements in seconds. I'm just listing in these boxes some quick conversions that you can use to get into those units of measure. For less common conversions, most formula sheets have a table that looks like this. We've got the prefix name in the middle column, the prefix symbol in the leftmost column, and then the conversion factor in the right column. So maybe we're solving a problem, and the problem says that a bullet flies north for 90 ns. So I want to find that prefix in the table. That is the nano, and the conversion factor is 10 to the negative 9. So when I plug in, and I want to be in seconds, I would use 90 times 10 to the negative 9th seconds. Dimensional analysis is related to more complicated conversions. Maybe we need to convert 50 kilometers per hour into meters per second, so kind of 2 conversions in one, or maybe 12 rotations per minute into seconds per rotation. If you want to try these 2 and check their answers, they are both included in worksheet 1.01. Next, looking at geometry. For circles, you'll want to know the difference between a radius and a diameter. You may need to calculate the area or the circumference of a circle. Both of the formulas included are related to radius r. For rectangles and triangles, you may need to calculate the area of them. B and h stand for base and height, respectively. And for 3-dimensional shapes, like cubes, spheres, or cylinders, you may need to calculate volume or surface area, and all of this information is likely on your course formula sheet. Next, looking at trigonometry, specifically for right triangles, I think the first important skill is to label the sides of the triangle with respect to a given angle. In this picture, that would be angle theta in the bottom left corner. The hypotenuse is the longest side. Notice that the opposite side is across or opposite to the angle, and the adjacent side is next to the angle. To relate the 3 side magnitudes, use Pythagorean theorem. The adjacent side squared plus the opposite side squared is equal to the hypotenuse squared. To get angle theta involved, you want to use your trig functions, sine, cosine, and tangent. Each of them are related to 2 of the 3 side lengths, so I think labeling your triangle will be an important skill. It will help you pick the right trig function based on the individual problem that you are solving. Next, looking at algebra, maybe we are solving for a missing variable, like variable x in these 3 quick equations. Maybe we are attacking a system of equations, which means 2 equations with the same 2 unknown variables. Here that's variables a and b. You are trying to solve for both. Or maybe we are attacking an equation that fits the quadratic formula, and we are solving for the value or values of variable x. All of these examples are part of worksheet 1.01 if you would like to test your understanding. From there, let's get into graph basics. Most graphs that you will attack in a Physics 1 course will be linear in shape, and therefore the slope-intercept form will be a good match. The y and x variables are what are being graphed. The slope is variable m, and the y-intercept is variable b. Calculating a slope will be important. That's rise over run, so the change in the y variable divided by the change in the x variable. So likely we'll be analyzing 2 points along the line. I've labeled some sample values as coordinates 0, 0, 4, 3, and I'll use those in my calculation as y2 minus y1, 3 minus 0, and then x2 minus x1, 4 minus 0, and I'll get 3 over 4 and a slope of 3/4. You may also need to calculate the area underneath the data, so you want to shade in the region between the data and the x-axis and focus on whatever shape is formed. Here that would be a triangle, and that's why we mentioned finding the area of the triangle as being important. That would be 1/2 base times height, a base of 4, a height of 3, and an area of 6. Also related to graphs are mathematical models. We are trying to write an equation that relates the variables that are being graphed. This is a linear graph shape, so we'll start with that slope-intercept form again, but we are not graphing variables y and x. We are graphing variables p and j, so I'll sub those into their respective places. The slope and the y-intercept can be found as numerical values. Being that I have 2 points labeled in this graph, I can find the slope as 0.5 with the units of rise over run, or L over V, and the y-intercept is a value of 1L. So this is a complete mathematical model. It describes the relationship between variables p and j, and I can use it to make future predictions. Let's talk about significant figures and rounding. Know that every classroom teacher has different expectations for these. You'll want to check in with your own teacher. I'll just recommend that you be reasonable. One of the major things that I see students do is turn in answers that look like what's on the left. I think that's too many decimal places. I think you'll want to round that up to be a nicer looking number like what's on the right. Lastly, most Physics 1 courses require the use of a graphing calculator. Make sure your calculator has the 3 trig functions, sine, cosine, and tangent, and make sure you can find the mode button and flip your calculator into degree mode, as that is the mode most commonly used. If you found this video helpful, then please consider hitting the like button and subscribing to my channel. You will help me reach more students. For more content videos, tutoring information, practice materials, and live review sessions, check out my website or follow me on my social media platforms.